Everyone, today I'm going to save you a whole lot of confusion by breaking down three terms that get thrown around like confetti. Today we're going to be talking about large language models or LLMs, automations, and AI agents. They are not the same thing. And if you lump them together, you're going to either overestimate what the AI can do or underestimate the possibilities. So let me explain what each of these are and what they can actually do, where they fall short, and how to spot the differences. I'm going to move my chart over here. We're going to start with large language models. So, large language models or LLMs, they are like the brains, for example, for like ChatGPT, Claude, Gemini. They are trained on a very large amount of data that includes books, articles, internet data, and human generated responses. They use a lot of Reddit data to train the AI. And you give the AI a prompt and it will generate a response. And that's it. So in the case here, we have Claude. When you fire up Claude, you'll enter a prompt into the prompt section, right? You tell it what you want, and then it will go through and do its magic and give you an output. And so this is where we have human, AI, human. And so the limitation of large language models is that, for example, you can have it help you write an email, but it cannot send that email for you directly to the recipient, right? So basically, they can simulate reasoning, give you information, summarize, translate, and even write code or lesson plans. But there's always a catch. They don't know if what they're saying to you is true. They have no memory of the past conversations you've had. Although with ChatGPT, it will start to learn about your conversations, but it still gets confused. And they don't make decisions. They are not doing anything unless you ask them to do it. So LLMs are like having a super smart intern, and you can ask them to write an email, but they won't decide to send it, right? Or you can ask for research, but it won't dig into the research unless you tell them what, where, and how to find the information. And so that's a limitation, right? So it has no initiative, no sense of action, and no memory. Um, and it can't access your tools, right? So that's a huge limitation. That's the next limitation. So again, it will only act when you give it an input. The black box basically is that data scientists and machine learning engineers can mathematically tell you how it's generating responses, but it cannot tell you how it's making the choice to give you the response that it's giving you because it is mathematically decided, right, based on weights. And it is just basically a text completion. In the case of images, it is taking your prompt and it's doing the same thing. It's taking the image, it's breaking it down into numbers in order to generate something mathematically for you. And then the output is something that's human understandable. So, but once it outputs it, it cannot send it for you. It can't do anything for you. So here you have to give the input. It will do something with it, right? Like let's say write an email. You tell it write an email to so and so. If you don't give it context, it's going to write a very generic email that may or may not meet your needs. So you have to give it context. And then it will write you that email, but it cannot send that email out for you because it doesn't have access to your email. It doesn't have that capability. So this is the limitation of a large language model. So next, let's look at automations, right? So here I have a sample automation for you. And there are a ton of different tools that you can create automations in. There's like Zapier, Make, and a ton of other ones that are commercially available. These are like middlemen for you, but these are like factory machines. and they follow your design in a workflow. So it's kind of an if-then situation. So if this happens, then do this. If this happens, then do that, right? So it's only following the design and the workflow that you give it. So a simple example is like a new employee is added to an HR system. And so you have a automation that goes from your HR system to trigger a message, right? So it will the adding the employee to the HR system becomes the trigger, and it triggers an email or a Slack message, or it creates a login in the LMS. So there's always a trigger in this, and it's mostly manual. And you can have multiple automations tied together. So one that says, when a new employee is added to the HR system, right, manually, send it to this trigger this event to send out an email to the new employee or a Slack message and add them to the LMS, right, or create their LMS login. It's fast, it's predictable, and it's efficient, but it's also cannot make decision. And it doesn't learn, it doesn't adjust, it doesn't ask question when something's off. And the problem with automations is that the more complex they get with like different tools and triggers and logic and conditions, it starts to break. And one error, one break will break the entire automation. Let me show you. So here's an example of an automation. I love going on YouTube and finding YouTubers that will share these super big automations. They're so impressive because you're like, oh my goodness, there's so much going in here. Like, how do I can never build this, right? That's the first thing we think. It's like, this is so massive, so big, so impressive that I would never be able to build it. And I will say to you that you don't want to build it, because as big as and impressive as this is a nightmare to troubleshoot. So just like I said, these big automations will break. And when one thing breaks, it is so hard to fix it, because then you may break something else, and it ends up being just a big mess. And no one wants to maintain something like this. So for example, let's say in this case, right, we see a lot of Dropbox icons in here. Let's say, for example, that the Dropbox login for the specific Dropbox has been changed. Your automation, this automation would immediately break. And these are the multiple failure points that you have. The problem is that unless you have a full view of this automation, you need to be able to test that once you update the login, that it will work across all the branches. And I guarantee you may not know if there's some information here that needs to be added, or here, or over here, or wherever it is. Like, you can have this domino effect of this huge automation just breaking. So it becomes really unruly, and it's difficult to manage. So you want to keep your automations simple. So here's a simple automation. This is a Google sheet that I have, and I tied in AI. Your automation does not have to have AI. It can be just the automation, or it can have AI in it. So in my automation, when I add a new row to a Google sheet, it will trigger an event that calls the ChatGPT, and ChatGPT will read the new row, and it will create a summary of whatever's in that new row, and it will update the row with that summary. So this is a very simple automation. So if this breaks, let's say the connection to my Google Sheet breaks, I can fix that, right? Because it's just the connection to the Google Sheet. If the ChatGPT, I need to update the completion or the prompt, I could do that easily because I know where my points of failure are. So this one I made and make, and I use it every day. I just want you to know that when it comes to automations, AI automations, you want to keep it simple, because if you create a beast like this to be impressive, when that sucker breaks, it is going to break completely, and it's going to be a nightmare for you to be able to maintain. So instead of trying to be impressive, what you can do is you can use agents. And so let's go to agents now. And this here is a workflow of an agent. When we talk about agents, large language models become the brain of the AI agent. And the automations are like, think of the automations of like arms for the agent. Agents are a full body system with a mission. And that's the best way I can explain it to you. An AI agent thinks, it plans, it acts, it uses tools, and adopts based on feedback. It doesn't respond, it initiates, it loops, and it learns. So let me give you an analogy. So there are two different types of automations that you can actually create. So the first automation is an agentic workflow. So in an agentic workflow, think of it like an automatic car wash, right? So you go to the car wash and there's predefined steps in a specific order that happen when you go through the car wash. So you might get, I don't know, your car may get wet first, then it adds some soap, and then you have the little things on the side that clean your car, right? Then you get sprayed off again. This is similar to what an AI automation is, right? Because your car may either have a sticker that already has a predefined, like you have a membership and a predefined, like you get your wheels shined and you get wax, or you may pay at a little machine, right? Tell it what kind of car wash you want. And then when you go through, it knows already what you have paid for. So this is one form of an agent. The next one is a full AI agent. So I want you to think of self-driving cars that can navigate the road and adapt to like traffic conditions and learn to drive more efficiently over time. Recently, Tesla had its first self-driving car that drove itself to its purchaser, so to the person that purchased it. There was no person behind the wheel. There was no pre-programmed steps other than like the address, right? It had to choose the best route. And it was able to get from point A to point B. This is what we call a goal-based AI agent. It had some basic information like you need to be delivered to so-and-so by like, I don't know, 9 o'clock in the morning. And here's the address, right? So it had to figure out the best route. First of all, it had to figure out the time. It had to figure out the best route. And then it had to drive itself there. And we know that roads are unruly. As drivers or passengers, you may have been stuck in traffic and crazy drivers around you. That is a very complex set of things that the car has to go through in order to be able to reach its destination. That's what makes agents different. You can give them a goal, not just a task. And a well-defined AI agent can break a goal into steps. And then it can decide what tools it needs. It can access the internet, your calendar, your documents. It can check its own work and improve. And it can collaborate with other agents. You can have something called the multi-agent system. So let's clear this up a little bit. So using ChatGPT is not using an AI agent, right? This is just one-off prompting. Even if you ask it multiple things in a row, that's you still doing the planning, right? You're still giving the instructions. An AI agent doesn't wait for your next prompt. It works until the job is done or it hits a roadblock and asks for help.